Swayam Prabha. Digital India. Educated India.
Okay, so let's go about it. Actually, let's try to understand. See, market equilibrium is another. So this is essentially we are going at the core of microeconomic, okay, theory of microeconomic, and then market equilibrium consists of important, they are like cornerstone in microeconomic theory. And originally, all this game theory and all development were, motivated by some of these market theories actually. So let's try to understand what it is. Okay. Okay, so let's take how do the prices get decided? Have you ever thought? For example, we'll go in the market and we buy tomatoes. I don't know what is the price of tomato today, but at least the time when I had prepared this slide couple of years back, that time it used to be sold at 20 rupees per kg. Okay, I hope it is at the same price. And the gold at that time was 3 rupees 3,000 per gram. I'm sure it must be much higher today. Let's say. So at any point in time, have you ever wondered that what decides the price of a commodity, right? Every day we buy and sell goods. These are called commodity or the goods, right? So what governs? Why the tomatoes are sold only at 20 rupees kg, whereas gold is sold at 3,000 rupees per gram, right? Or whatever price, right? For that matter. Why such a big difference? Yes. Can you speak little loud? Value? National market. Value in the national market. International market. Okay. Anybody else? Sorry? Not easily available. Okay. 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 Very good. So you are almost, very close to the answer actually. So what I hear by and large, it is the demand and the supply, right, which decides the prices actually. Am I right? So if you take some quantity or some commodity, if the demand is very high, but the supply is not so high, obviously that will become a premium quantity, right, or premium commodity, and the prices will start shooting up, right? Imagine that there is a shortage of crude oil in the country, the petrol prices will go up, right? Very simple. Or some year, if the production of the tomatoes is very high, let's say monsoon is good, soil condition and weather condition is good, and tomatoes are produced in bulk, nobody is there to buy, then what will happen? The farmers will be willing to sell them at a much lower price, because otherwise they will anyway go waste actually, right? Okay. So the rough idea is clear, intuition is clear. Let's develop it further. So how does the economic activity work in any country? Okay, this is how typically any economic activity work, and this is the most abstract model of economic activities. So what do we have? We have these elements. One is called consumers, another is called commodities, third is called production firms, and then there is this thing called money flow. Okay. So what happens? Consumers consume the commodities. This commodity, who produces the commodity? Production firm produces the commodity. So here even farmers can be viewed as a production firms, doesn't matter. Don't take it in a literal sense, but it is by and large more abstract notion of production firm. Anything which produces something which is consumable by consumers. That is what we are calling as a production firm. For example, a farmhouse could be a production firm, can be viewed as a production firm. Institute, this educational institute can be viewed as a production firm actually, where we are producing the intellects actually, right? Who can be hired by, let's say, some companies or some other technical institutes, right? That way, it's a more abstract notion. Now, how does money flow? So, consumers who buy the commodity, obviously this money goes back to the production firms, right? Because who produce the commodity? The money flow is in inverse direction, the material flow is in forward direction, the money flow is in the reverse direction. Make sense? But these production firms, do they have their own standing? Like, they cannot exist at their own. Some human being only have to bring them to the existence, maintain them, run them, etc. So entire population or entire nation's population, if it is put in this consumer set, then some of this consumer only will be the ownership of the production firm also. Am I right? So at the same time, I may be a producer of some commodity, I may be a consumer of some other commodity also, right? So these firms or the production firms are being owned by the some of the consumers. They don't have their sole identity as such. So we will come to that. Before I get into the too much formalism, let's first introduce the history. So this economics had seen several eras. Up until 1870, the period of economics is known as classical economics. Okay. Next 100 year, 1870 to 1970, that is called neoclassical economics, and then after that it's a modern economics actually, after 1970 beyond and all that. So up until 1870, there were some of the pioneers who started setting the foundation of theory of economics. One of them pioneer being Adam Smith, okay, and he is also called as father of classical economics. So there were other stalwarts in that period. Robert Malthus, so Smith and Malthus theorem is very famous. Like you say, roti, kapda and makan, all this came from this, Smith and Malthus theory actually. Like all this, the central thing which governs all the activities, the need for roti, kapda and makan, right? All these things was there. This is where they started with this simplistic view. Because there is a genuine need for a human being, in search of that, in order to satisfy those needs, all the other activities are like centered around them, kind of right? So to say, in a very simplified form. So what they did is, so Adam Smith first started asking this question that, the nature and the cause of the wealth of the nation. So first they started asking, because in those days it used to be kingdoms, right? Actually, this kingdom, that kingdom, some kingdom used to be much more wealthier than some other kingdom, right? Today we see the nations, but way back in those times, the nation's geopolitical boundaries were not that, clear-cut defined, and it used to be more of this, these kingdoms actually. So then the question used to become, how do you measure the wealth of a kingdom or wealth of a nation? Should it be measured by the reserve? See, every kingdom used to have certain reserve of gold, certain reserve of currency, or some stockpile of, let's say, goods. Does that define the wealthiness of a kingdom? People used to think earlier that way, that if your kingdom has more gold accumulated inside their, storage, or more kind of, wheat and rice is stored, that is more wealthier kingdom. That used to be the perception. But then people like, Smith and all came. They said that that's not absolutely the right way of thinking the wealth, to measure and quantify the wealth of a place actually. It's not the reserve which you have. What it is? Instead, it is the economic activity which takes place in that kingdom that determine the future and the wealth of a nation, not the reserve actually. There is no point in a country where there is a huge amount of stockpiles of reserves of the assets and ornaments and food, but then all people are sleeping, no activities are happening, right? That's not a wealthy nation in their view actually. Okay, so they started talking about the notion of, they started this inquiry that what is the nature and the causes of the wealth of the nation. First of all, how do you define the nation's wealth? What should be the nature of the wealthiness? When you say this nation is wealthy, what do you mean by that? And what are the important causes behind making some nations are more wealthier than some other nations, right? That's the very, very classical piece of work. This also published in 1776. This is called Wealth of Nations. So they laid the foundation of something called as free market economic theory, which you keep hearing in many of the talks. What is free market economic theory? So the free market economic theory says that market should be left free to operate. See, in earlier days when this kingdom used to be there, everything used to be governed centrally by kingdom actually, right? They used to dictate everything, they used to decide the price, who will sell what, who will produce how much, everything is centrally governed, right? They used to call that, this, what's the lagan and all those things they used to give, which used to go and sit in their stockpiles, how much tax they will put, everything was like this government dictated actually. So what they said is, they started giving it the new philosophical thought, right, out of the box thinking that let's have free markets actually. What do you mean by free markets? The market should be left free to operate because price mechanism acts as a powerful invisible hand to allocate the resources efficiently. And this invisible hand word this coined by him became so popular in economics books. You will see that maximum amount of time you repeat this word called invisible hands. We say that market has invisible hands. And these invisible hands, what do you mean by invisible hand? So if you leave the market free, if you leave the people buy and sell among each other and trade among each other whatever price they want, over the time it will so happen the commodity will get settled at some price, right? Like in stock markets and the trade market and share markets you see, and demand and supply gap will automatically decide that which commodity should be expensive, which commodity should be cheaper, right? This is called the freeness of the market. Don't put any control. Don't say that, okay, this commodity should be traded only at this price and that price and all of that actually. So this kind of philosophical thought started emerging, right, from some of these people. Then, so their emphasis was on price. What they say is, in entire economic activity, the price is the central actor and nobody controls the price. Price is something which is controlled automatically. That's where they use word called invisible hand. Nobody should control the prices. Let prices get controlled automatically depending on how people buy and sell the goods. So if I have something, if I am willing to sell, if you are interested in buying, let them debate. I mean, let them negotiate between each other and settle at some price, right? You may further sell to somebody else, then you debate. Eventually, if the market is big enough, every commodity will settle at single price. And that's what we want to study, the dynamics. How will it happen? If the markets are left free, people are left free to trade among each other, how the price dynamics will work? That was one of the important central question in this entire theory, and we wanted to touch upon them. Now, it has a connection with game theory also, right? In fact, game theory plays a very important role in coming up with the settlement price actually. Okay, so after that, this 1870 to 1970 era, this is called neoclassical economics. Here, people like Leon Walras, he was a French mathematician, economist. Then there are few another name, Carnot and Pareto. You would have heard Pareto optimality or something like that. So Pareto comes from this one of the pioneer, right? He was in this era, he was one of the well-known economists actually. Similarly, Carnot, duopoly, oligopoly, I don't know if some of you have heard, right? So Carnot was one of the very important person who played an important role in the advancement of neoclassical economic area. So how are they different from classical economics? So in this period, the methods which were proposed by the earlier generation, namely free market economic theory, that started becoming more and more grounded, okay? The methods become more scientific, okay? And the focus started shifting from free market economy to something called competitive market economy, okay? Free market economy was very abstract, I mean very general, okay? You freely trade among each other, price will settle down automatically. Beyond that, probably they did not went further too much detail into it. How will it settle down? Can you mathematically prove me? These are all in talk, right? How will I convince that indeed what you are saying is true? That there will be invisible hands which will control the price, which will act as a price controlling mechanism and will drive the prices to an equilibrium. Can you convince me? Those things were missing. And that's where people like, Walras and all, they came up and started putting a nice mathematical formulation around the whole problem and then gave the very convincing answer. Let's try to see that. So what their idea was, read the third bullet. This was the main central idea between this Walras theory. What they said, in competitive market economy, the agents, so buyers and sellers are called as agents, okay? So economic agents are rational in their behavior. What do you mean by rational in their behavior? That consumers will look to maximize the utility and firm will look to maximize the profit. Allow them. So consumer, let them decide what object or what quantity or what commodity they want to buy in how much amount. Then let them figure out which is in their best interest, they will go ahead and buy. Every consumer, let them operate in an autonomous manner. Same, every firm, don't control them. Like king should not come and tell, no, you produce this. Let them decide what you want to produce actually, okay? And that will result in a price discovery mechanism. Automatically, things will get settled down at some price. Let's see how it works. So let's try to work with a very simple mathematical model of competitive market economy. This is how it works. So you have commodity, let's say a bunch of commodity, I put them in the column, Okay, this could be very large set actually. Put anything which can be traded as one of the column. Okay, now you have bunch of consumers and bunch of production firms, right? Now what goes inside these cells? So let's start filling some of these numbers. So without loss of generality, these are called initial endowment. Initial endowment means, suppose consumer 1, how much he owns to start with before, let's say, economic activity starts. Suppose think of that, we all came in this room, and now imagine that like how you go into many times this downtown markets, right? Actually, where people trade with each other. The very first picture in the starting of my slide I showed you, right? Somebody brings some item, somebody brings some another item, and people start buying and selling, right? So here, imagine that on the beginning of the market or beginning of the day, the consumer 1 owns different commodities in these amounts, like W11, W12. This is the bundle which agent 1 brings to the table in the beginning of the market actually. Let's say, when I say beginning of the market, it is little vague, but you think of that this is like in the beginning of some event actually, okay? So each agent is bringing their own endowment. These are called initial endowment, and this capital W1 is the entire vector I call as a W1. Now this column, the sum of the column will tell me what? This is the total supply of this good in the market, right? How many total breads are available across everybody? This tells me the total how many breads are available in the market. How many total tomatoes are available in the market. So the column sum will tell me the total supply of each of the commodity, and the row vector tells me the endowment of each of the individual actually. Alright. Now there is this something called production firms, right? So what happens this production firm? The production firm, each of the production firm without loss of generality may also produce some of this commodity. I have not written here, but let's say that they can also produce the commodity. Each of the firm, so for example, if some firm produce only tomato, then the other entries will be 0. But without loss of generality, this is some matrix actually, okay? So that was supply part. Now there is one more thing I was telling you, that this production firm don't have their own standing. They has to be owned and maintained by some consumers, right? So let's say each consumer without loss of generality, we say that they own certain share in this firm. Like each firm is jointly owned by, maybe jointly owned by multiple consumers, right? So for example, firm 1, this is theta 1, theta 2, 1 and all. This tells the ownership share, because firms are not a living entity. Think of some factory, right? Somebody will be owner of the factory. Somebody will be entrepreneur of that factory, either one individual or two individual or multiple individuals. Nowadays you see that like you buy the shares. What does it mean actually? I mean you own the tiny portion of the entire production firm. That's what it means essentially. So these matrix tells me the column sum has to be 1, right? Because this is the ownership of this non-living entity, namely firm, how its ownership is distributed across all the consumers, like that. So now what next? So earlier we talked about the production, right? So in the previous slide, I told you about supply part. This is the supply part, supply or production. So the availability of the goods may come in two forms. Either every consumer immediately bring these goods from whatever they bring, from somewhere, let's say they bring. Another option of the supply of each good could be some production firms are producing them. So this is the supply part. Now let's come to the demand part. What is the demand part? Let's say each of this consumer, this X, X11, X12, X13, these are called the consumption bundle, in the sense that if consumer 1 consumes X11 amount of bread, X12 amount of tomato, X13 amount of gold, then we call this as a consumption bundle, let us say. What is this consumption bundle telling? And let's say P1, P2, P3, Pk are the current prices at which these commodities are being traded in the market, suppose, right? What does this consumption bundle mean? So a consumption bundle mean, and this is the production bundle, like each of this firm is producing each of this quantity in this much amount, okay? And these are the demand of each of the consumer for different quantity. Some of them could be 0. In fact, large number of entries in a row will be 0. So this entire vector is called the consumption bundle. So every consumer who consumes the commodity gets some utility out of it. That's what this utilitarian model actually. So if we go to the next slide, we define something called utility function. So this function is nothing but a mapping going from this entire space, this k dimensional vector space to R, but not the k dimensional space, because it doesn't make sense to buy negative quantity, right? Consume negative quantity. Sometime it may be consuming negative quantity means producing that quantity, right? So there is this notion called utility, okay? So this is the notation. Now let's come to the interesting part. So how do you define this something called Walrasian competitive equilibrium? This is also called Walrasian equilibrium or competitive equilibrium. So this was the very classic piece of work and one of the most important result in economic theory. When you read any of the microeconomic theory book, this is one of the most important topic called Walrasian equilibrium. What does it mean? So it says that allocation vector x1 star, x2 star, xm star and y1 star, this is the production vector, right, for the firms, and these are the consumption bundle of the consumers, these are the production bundles of the firms, and a price vector p, together they forms the equilibrium. So how much each consumer should consume, how much each production firm should produce, and what should be their prices. Is there any locking such that they get locked now? What is that locking point? That equilibrium point? That equilibrium point is called Walrasian equilibrium if the following conditions are satisfied: profit maximization, utility maximization, market clearing. What is profit maximization? So for each firm J, the firm, if the P star is the price vector and Y is the plan for production. So let's go back to this picture. So suppose this is the firm, right? And P1, P2, Pk are the prices, and if this firm starts producing, let's say Y11, Y12, this is, let's say, production bundle, suppose. Okay, let me go to, yeah, suppose this is the production bundle and these are the current prices in the market. How much will be the money after selling them or after disposing them in the market at these prices this firm will make? You take this number, multiply with this number, take this number, multiply this number and sum them up. Am I right? Because I have this much quantity of bread and per unit quantity of the bread is being sold, traded in the market at P1 price. So if I sell dispose all my breads in the market, assumption is that somebody taker is there. We will come to that part. Then I can make how much money? Y11 into P1 and here Y12 into P2 and so on and so forth. So this is essentially taking the inner product of dot product of this vector with this vector, right? And that is called as the, the revenue I will generate. This firm will generate this much money, right? Similarly, if this consumer has to buy this many quantity of the goods, the consumer has to shell out this much money from his pocket, right? And how much money he will need to buy this many goods? If his consumption bundle is this, then again you take the inner product of this price vector with this consumption vector. That is the amount of money you need to buy all these items. Is it clear? Making sense? Okay, so let's go back here. So what it says, given the price P star, every firm will try to produce the vector which maximizes their profit, which maximizes the revenue, right? Similarly, given the price vector, each agent, each consumer will try to consume a bundle which maximizes his utility, because with every consumption bundle, for example, I like gold more than the tomato. There are some people who may prefer to have gold than food actually. I'm just cooking it up, right? In which case, my utility may be higher. If somebody gives me more gold, I'll be happy even if I am dying from the hunger, right? If my utility is like that, right? Whereas some other people care only for food, they may not worry about ornament. In their case, their utility may be different. Whatever may be the utility, this UI tells reflects your attitude, your behavior, and every individual have their own behavior and they are free to have their own behavior. That's the beauty of these free markets, right? So, given that a consumer I, UI is his utility function, which decides that if X is the consumption bundle, how much pleasure or joy he or she gets out of consuming this commodity, then obviously he or she would like to consume that bundle which maximizes their utility. But at the same time, we know that in order to buy those commodities, you should also have the money. Where the money will come? So P star into X. So suppose X is your utility bundle, suppose. Then P star X is the amount of money you need to buy that. See, if you go to shopping and you say, I want to buy these many clothes, that food, this ornaments, you need money, right? And this is your amount of money needed if this is your purchase plan, right? But then You also have initial endowment. You remember that WI we were talking. You can, whatever commodity you have, you may want to sell them off and get the money back, which you will use for your new plan. So on the right hand side, one source of money for you is what? Your current endowment, WI, which you can dispose of in the market and get the money back, which you can use that money to fund back your new purchase plan. Plus, you also own certain ownership in the firms. So if each firm is making this much revenue, because you are the owner, for each firm you may own certain ownership. If you are a consumer I, in the jth firm you have this much share, theta ij. What does it mean? If that jth firm makes this much revenue, this much portion of that revenue is yours. That's another source of funding for you. So what you have to make sure that this left hand side is less than equal to the right hand side. The required money to make purchases should not exceed the supply of the money you have, right? So each consumer will be solving this optimization problem.
There is no constraint in the first optimization because we are assuming that Y3 is entirely consumed.
No, I am just producing. What kind of constraint you have in mind? Some things are not consumable? No, but so then price will decide that actually. So for example, if somebody is not buying my good, which is as good as the price is 0. See, we will model it in this manner. Suppose I have this bottle and I want to sell anybody and nobody is willing to buy. I can throw it off, which is as good as I sold it to you at 0 price. Throwing it off is as good as selling it the price at 0, isn't it? So without loss of generality, everything fits in place actually, okay? In fact, that will have very interesting implication now. It is something called free disposal actually. So the commodities whose prices are 0, they will be available for free disposal. In fact, that's like headache actually. People may want to dispose it off, right, actually. So we'll come to that. And the last condition he said is market clearing. For each good, the total supply should be equal to the total demand. So look at the left hand side. If you have the good K could be either bread or tomato or gold or whatever it is, I am just summing it up over all agents, all the consumers. That is the total demand of this commodity K. And on the right hand side is the supply. Where does the supply will come? So one supply may come from this initial endowment WK. Another supply may come where the firms are producing these different goods, right, actually. So I am just summing it up over all the firms about their production plan. So this will be the supply from the firms actually. So this should be equal. So Walrus idea was that if you put bunch of these players, actors in a room, let us say, where people decides on, you know, how much to produce, how much to sell, how much to buy, what to buy, depending on their individual utility, then finally the market will settle down at those price vector P star which satisfy all these conditions. Any question? WK is the initial endowment. Initial endowment means, for example, before we all came in this room to start this economic activity, from my home I bought 1 kg tomato, 2 kg onion, which I want to dispose of. I am okay to dispose it off. That's like my wealth in indirect form. So if somebody needs tomato, I will give tomato, take the money back. Potato also I can give them. So there is a common pool. You can think of that this is the common pool actually. Everybody can come and deposit their current ownership of the different goods, take the money back. Now here are the goods. Now you take whatever bundle you want back actually. Think of it this way, right? I mean, it's just a perception how you want to view it. Doesn't matter. Okay. So what he says is that for any alpha greater than 0, multiplying equilibrium prices with vector with alpha preserve the equilibrium. What does it mean? So if we have some price vector P star, and if I multiply this P star with some constant alpha, which is strictly positive constant, that won't disturb the equilibrium. Essentially what it means, that if you solve this all these three optimization problem at the same time, profit maximization, utility maximization and market clearing conditions, if there is some P star, what is given to you? You are given only the utility postures. See, the utility of each agent is given to you. The ownership of each agent, this production firm, how much profit, how much share you have in each of the production firm. These theta ij's are given to you. These UI functions are given to you. That's all. These are the two things are given to you. The solution of all these three problems together jointly you have to solve the three things. Who should buy which quantity in how much amount? Each firm should produce each commodity in how much amount? And what should be the trading prices actually? These are the questions. At the same time you have to resolve all these three questions. So what they say is if you solve this, so any such x star, y star and p star is called Walrasian equilibrium if you can have such a pair which satisfy all these conditions actually, okay. And if you have that, we'll come to that whether it exists or not and how do you compute and all, these are all the questions I am going to come to. But first I want to define this notion called equilibria, market equilibria or Walrasian equilibrium. What is that Walrasian equilibrium? A plan. The plan consists of three things. Which consumer should buy what commodity in how much amount? Number one. Which firm should produce what commodity in how much amount? And each commodity should be bought and sold at what price? These are the three unknowns. If you can assign these values to each of these three unknowns such that they satisfy these three conditions. What are those three conditions? I should assign the prices to the commodity in such a manner that the production plan of each of the firm is their profit maximizing plan, which means there is no other plan at which they will find it to switch over. So suppose these are the production firms, these are the consumers and I am the consultant. I comes and tell each of you that you produce each of the quantity in so and so amount. I come to each of you and tell you buy this in this much amount. I know your utility function, each of yours utility function. I know the membership share, how much share you have in each of this production firm. I also prescribe the prices. Then I ask this question, I am a consultant, I will walk out of the room. After that, do you want to deviate from my recommendation? Each one of you. If you are a production firm, you will say, go to hell, why should I listen to this consultant? Let me change my plan, can I make more profit? So if prices are not altered, right? Then if you realize that whatever consultant recommended me, that seems to be the best plan for me to produce, because any other plan if I produce, my profit is going to be less. Same with consumer. They may say that why should I listen to the consultant? I will decide my own purchase plan actually. I may be more happy. But if I can guarantee that no matter how hard you try, you can keep trying as many days as you want, you will not be able to arrive at better purchase plan which will make you more happy than what I am telling you. Then you are all in logged, right? You are all in equilibrium situations. So the question now becomes, can we find this? First of all, does there exist this purchase plan, the production plan and the consumption plan and the prices which put all of these parties in a locked situation, right? This is called equilibrium situation. If it exists, then how do you compute it? Fair, good with me? All right. Yeah. That's a good point. Actually, all of you are coming to that. I'll come in a minute. Doesn't matter. Even if the supply is, I could have written it greater than or equal to 0. I think your discomfort is that why are we writing them strict equality, right? See, then, so certain commodities whose supply is more than the demand, the equilibrium prices will be 0. I mean, there is something called complementary slackness condition. If time permits, I'll go into that. So rest assured that some commodity where there are no takers, if the supply is more than the demand, then what will happen is their price will become 0. So we call them as a free dispose. Whatever is surplus, think of that I am the guy who you throw on me whatever is surplus. Nobody is taking something, you throw on me actually. Anyway, I don't have to pay to you. So I am like a dustbin actually, right? Think of that actually. You can throw everything here. There is a one dustbin place. It's called free disposal. Put a dustbin, call that as a one consumer. Some extra artificially added dummy consumer who will take away all the extra supply. As long as the dabba doesn't have to pay to the market, what is the dabba's problem? But market will still clear. I mean, it's a hypothetical way of setting out this. So that's not a problem. Even if it is an inequality, by introducing one dummy consumer, I can satisfy this inequality. It's just that dustbin neither contribute to any money. Think of that there is a virtual consumer, right? He doesn't have money. So only thing he can buy is the commodities which are sold at 0 price and nobody is willing to buy. We'll come to that condition. Huh? But good thought. Okay. So, so let me just skip this part. The important part comes is the existence of Walrasian equilibrium, right? As we talked about, who guarantees me such a plan will exist? Will there be some locking point will always exist? So here comes this very important results by two well-known economists, Kenneth Arrow and Gerard Debreu. Both are Nobel Prize winner in economics in 1972 and 1983. So they had fantastic phenomenal paper in Econometrica. This is one of the top class journal in economics, and this paper, existence of an equilibrium for a competitive economy. So there they try to prove the existence of equilibrium of the previous setup which I just talked about. What they did, so before that in 1936, Wald had given another proof for the existence of equilibria but under severe restriction. But in 1954, Arrow and Debrew came up and they gave a proof for existence of equilibrium under much milder condition, namely concave utility function. There are few other technicality conditions, I am not going into the detail. What they said is, as long as your utility functions, UIs, we talked about them, right? As long as those utility functions are concave utility function, and we have seen in the morning what is concave functions and what is convex functions and all that, right? So as long as they are concave utility function, they said that you are roughly good to go. I mean, you can always find, there will exist an equilibrium, okay? Finding is yet another issue, we will come to that, okay? So now the question becomes is, and of course this is considered to be a landmark result in the theory of general equilibrium in economics, and they reduce the problem to a fixed point problem. Again, I am not going into too many detail, and then prove the existence using Kakutani's fixed point theorem. I assume that in one of the lecture they will cover about this Kakutani and Brewer's fixed point theorem. I don't know what is the plan. I mean, this is how you prove the Nash's existence theorem also, right? Okay, so let me just induce something called exchange economy, which is a very special case of this, this Walrasian setup which we saw. In exchange economy, what happens? In exchange economy, there is nothing, no production firm, no production doesn't happen. By name, it suggests exchange, which means certain people have certain goods and we exchange with each other. There is no production firm, nothing new is produced. So there is nothing like production firm. Obviously, if there is no production firm, there is no question of production. This matrix disappears from the scene. If there is no production firm, there is no question of the ownership, because this is completely absent from the market. What is there? All the people are divided into two categories called consumer. Same person may play the role of consumer, okay, buyer and seller. We will come to that. So suppose you come with this initial endowment of the goods. You start the day with, this is your initial endowment. Each of the consumer has different amount of this quantity to begin the day, right? And at the end of the day, they just exchange the goods with each other. And at the end of the day, when the market closes, let's say this is the ownership of the goods for the same consumer. So this is when the day began, this is when the day ended, suppose, right? So now what? Let's go next. So so suppose this, of course, utility functions has to be there, because for any bundle there is a utility for consumer. So this was the bundle which consumer was having in the beginning of the day. This is the bundle which consumer possesses at the end of the day. Obviously, utility has to go up. Otherwise, why will I do this economic activity? Otherwise, the market doesn't make sense, right? We all go home in the beginning itself, actually. But then the idea here is that whatever different amount of different commodity I am owning, by exchanging them with some other commodity, I will also be happy and you will also be happy, right? That's the idea, actually. So this is a very special case. So this is called exchange economy. And how does it work? So in pure exchange economy, the allocation x1 star, x2 star, xm star, this is what, when you go at the end of the day home, this is what you take home. And the price vector p star, this constitute a Walrasian equilibrium if the following conditions are satisfied: utility maximizations and the market clearing via free disposal. That's what I was talking. So suppose there is no production firm, then if P star is the price you set in the market, then at the end of the day, every consumer will try to take the bundle which maximizes their utility subject to their wealth constraint. And what is the wealth constraint here? Because initially in the beginning of the day, if they come with this much ownership of the good, they can sell it back in the market at this price P star, right? So this will be the money they will get right hand side. Now here you see that second term is missing, that theta term, because that wealth they are not getting because there is no production firm in the market now. Making sense? And market clearing via free disposal. So this is where your question comes, that total supply, this WK is the sum of the column. The kth column if you sum all the entries in the kth column, that will give me the total supply of that commodity. Make sense? That supply should be greater than or equal to the total demand of that kth object. And what is the total demand of that kth object by end of the day? You take this allocation matrix, take the kth column, sum it up. That will be the total demand. So this demand should be less than equal to supply. Okay. Now the question becomes is, again the same question, obviously if the previous result Arrow-Debreu theorem was applying for the more general setup where you also had the production firm, right? Now it's a special case of the previous result, so obviously the equilibrium has to exist even here also as long as your utilities are concave function. So this is what the important characteristics is, and that's easy to show. If you look at any commodity K, this equation has to be satisfied. What is this equation? This is what I was telling, complementary slackness condition. At the end of the day, if the price of a commodity is Pk star, Wk was the supply in the beginning of the day, Xk star is the total demand of the goods at the end of the day. This product of these two terms should be 0. What does it mean? It means that either demand is equal to supply. So if demand is exactly equal to supply, then price can be non-zero. In fact, if price is non-zero, then the only way I can satisfy this equation to be 0 is that this Wk be exactly equal to Xk, right? If Pk is 0 for some commodity, if the price is strictly greater than 0, the only way this complementary slackness condition can be satisfied is the demand be exactly tightly equal to its supply. But if for some commodity, if this is 0, this quantity need not be 0, it can be anything, positive and negative.
This is just one coordinate of.
Yeah, this is one coordinate. It's only for kth commodity, but this apply for every commodity. So at equilibrium, this condition has to be satisfied. Okay. Now, if for some commodity, if Pk is 0, if this price vector is 0, price of let's say tomatoes is 0 by end of the day, then the total supply, obviously this constraint has to be satisfied. The total supply cannot be less than the demand, but total demand may be strictly less than the supply, which means there may be some surplus in the market. And why there is surplus? Because tomatoes are so damn cheap actually, they are at 0 price, nobody is even charging you anything, even you can take them for free. Getting my point? And that I guess answers your question. Is it making sense now? Right? So this is the beautiful constraint, this is called complementary slackness constraint, this has to be satisfied. So automatically things will be okay. I mean, you can put a free disposal means you put like analogy I was giving, some dustbin you put and you come and dump. That's what happens, right? Many times you have seen farmers destroy potatoes, farmers destroy, you know, some surplus the crop because they are not buyers actually. What do they do? Okay. So now the question may become, we have been talking about these concave utility functions. So what are the examples of concave utility functions, right? Because that Arrow-Debreu theorem we talked, right, that existence of equilibrium happens only in concave utility functions, right? So here are the some simple functions. For example, if you have the k commodity, it's called linear function. So you take the xik is the amount of that bundle you consume. Let's say this is the amount of potato agent I buys, and aik is the coefficient, some constant, that how much enjoyment you get by consuming 1 unit of potatoes. Same coefficient you can have for let's say tomato, gold or anything, then this will be a total utility. This is one example of a utility function, right? This is a linear utility function. Then there is this another famous example called Cobb-Douglas utility function. Then there is this thing called Leontoff utility function and things like that. So all of these functions satisfy, you know, this concave nature in the sense that if you plot these functions in the x space, where x is a consumption bundle space, then they look like a concave function. Okay. Okay. So there is a further special case of exchange economy which is called Fisher markets. So we talked about Walrasian markets, Walrasian equilibrium. Then from the Walrasian markets we removed the production firms, that becomes exchange, pure exchange economy. Now from further what we will do is we will have further special case called Fisher markets actually. Any question? Okay. No, that is Ronald Fisher actually, it is different, okay. There are different Fisher actually. Sorry? I don't know actually, okay. Alright, so Okay, so what is Fisher market? See, so far we talked about commodities, the supply of the commodity, demand of the commodity, price, but we never talked about money. Can you, so see, this is an interesting thing. So money is just a notional actually to be, I mean, if you think of it, money is just a notional. Although money becomes the center of everything, but if you think of in the previous thing, entire life can go on without even money, right? What is important is price, right? Like olden days, this barter system, if you think of that, right? As long as prices are determined and we have the commodity, the entire economy can go on. It's just that it's very hard to, you know, keep track of those, how much potatoes I sold, so, okay, I am due this much utility from you. That's where the notion, entire invention of money came into the picture. Why do you need money? I mean, if you think from an economics perspective, what money does to the system? Money is after all a paper, right? It's a piece of paper. But money is needed to do in a very distributed manner. It keeps track of accounting. So for example, if there is some commodity K, I have the amount XIK of that commodity and it is being traded in the market at price P star. If I give it to somebody, in net I should be getting, you know, XIK star into P. This is kind of a utility which I get back and I should be use that utility in some other form, right? So money basically facilitated is the job actually, right? Think of it this way. So far when we talked about this competitive equilibrium as well as exchange economy, there was no notion called money. But in Fisher markets, there is another things pops up called money. And you would be surprised to see that in this kind of modeling framework, money is also viewed as a commodity. For economists, money is also yet another commodity like potatoes, tomatoes and things like that. Money is yet another some commodity. What else? Think of it. Like you own the cell phone, I own the bottle, I own the money. That's all. The exchange rate of money is what? If I have to exchange money with itself, is a 1, right? So the price of money is 1. I mean, if you normalize all the prices actually, 1 unit of money, like 1 unit of potato, you give it to somebody else, you will get some money back. But money with itself will get exchanged at 1 rate, right? So money can be viewed perfectly fine to view money as yet another commodity like potatoes, tomatoes and things like that. The price of it is 1 with itself actually, okay? So now what happens? Now things becomes interesting. So money becomes a commodity in Fisher market. Again, you have all these, you know, commodities including money and you have supply of. So in Fisher market, what happens? They divide all the consumers into 2 categories. One set of consumers are called purely sellers. Another set of consumers are called buyers. In fact, physically same person may play the role of consumer as well as buyer. But for analysis purposes, let's give the different ID. Even if I am buying and selling something, I'll have 2 roles. I'll be wearing 2 hats, right? Buyer hat and the seller hat. Okay, so another assumption they make is, let's assume for the sake of simplicity, each seller can sell only 1 commodity. See, even if one seller is having multiple commodity, you can split them into multiple copies, right? And make them as if I am having 2 items with me, I can make 2 copies of mine just for analysis purpose, 1A and 1B. And 1 copy I say that, okay, 1 copy owns only bread, another copy owns tomato. But physically they may be the same owner, doesn't matter. But it makes the analysis much simpler. So there are bunch of sellers, each seller is selling this unique item, unique commodity. And there are these buyers who are interested in buying this commodity. Buyers comes with the money and the seller comes with the items. Simple, right? Buyers comes with the money. In the market, they enter the room with money and sellers enter in the market with the goods. And then the exchange takes place. So what happens? Let's try to understand this way. This is more a simpler picture. So suppose on the left hand side, there is a B1, B2, BM. Each of them is a buyer who owns the money M1, M2, MM. This is the amount of money they have in their pocket. Each of them is seller S1, S2, SK. If there are K commodity, I can put K nodes. Each of them is having this initial endowment of W1, W2, WK. And now these are the prices P1, P2, PK, which we don't know. And X12, this is again the amount of consumption, which we don't know. Like this buyer should buy how much amount of this good from seller 2 that we want to decide. So what is the problem now? The problem is, see, these M's are given, the red numbers are given to me, black numbers are not given to me, right? I need to assign some number for these black quantities. These black ones are unknown, red ones are known, and I need to assign some values to the black such that what happens? Such that, again, those equilibrium condition, that for each buyer, this is the utility maximizing bundle. For each seller, it is the profit maximizing and the market clears. Okay. So let's just write down those conditions. So he is Irving Fisher, not Ronald Fisher. You are asking, right? He is a different Fisher. So what he said, in Fisher market, the allocation x1 star, x2 star, and xm star, and the price vector p star, they constitute a Fisher equilibrium if the following conditions are satisfied. One is called utility maximizing. For each consumer I, we allocate them the goods which maximizes their utility subject to this money constraint, and for each good we make sure that the demand is equal to supply, right? And of course we have seen that Arrow-Debreu theorem says that if utility functions are concave, then Fisher equilibrium will exist, because this is a further very special case of general market equilibrium. So Arrow-Debreu theorem applies here, there, so Arrow-Debreu theorem applies here as well. Your utility functions has to be concave, that's all, right? And in equilibrium, each buyer must spend his full budget. You will find that in the equilibrium, each buyer's entire money will be exhausted, right? And Fisher equilibrium is a special case of Walrasian equilibrium under the exchange economy. Now there is another interesting thing called gross substitutable property. So if Fisher market satisfies the gross substitutable property, then the underlying Fisher equilibrium would be unique. That's a very important point. What am I saying? Fisher equilibrium will always exist as long as utilities are concave due to Arrow-Debreu theorem. But whether it will be unique or not, we cannot say. There may be multiple equilibrium points. There will be multiple price vector at which market may hit the equilibrium. But there is another condition, if your goods satisfy GS property. What is GS property? I am going to tell in a minute. This is called gross substitutable property. If your goods which are being traded in the market, if they satisfy the GS property, then the Fisher equilibrium will be unique. Okay. So what is GS? Let's try to understand that. Okay, maybe I should introduce this. So there is this, another very interesting problem was, okay, so see, so far we have not talked about how do you solve it actually. We just talked about this existence and blah blah, under what condition it exists because of Arrow-Debreu and all. Then you may wonder that even in the previous example, right, you may wonder, sir, if somebody gives me this graph, very large graph, and somebody gives me these red numbers, how do I compute this P and X such that they satisfy, you know, all these conditions actually? How do I compute? Because I have to have an algorithm, right, in computer. If computer can't compute, then how can market can compute, right, actually, if supercomputer can't solve this problem. So the question now becomes is how do we solve this problem? And that's where, you know, lots of this algorithmic game theory work has gone into. There is a huge amount of body of literature actually, very mature body of literature on algorithm for computing market equilibrium, right? So one important point, although I am not going into too many details about those algorithms here, time is not allowing me, but I just wanted to highlight this important development which happened in this whole area. So there was this famous paper by Eisenberg and Gale in 1959, where what they said is that, of course, that was for a special condition under linear utility case, which was later on extended by, you know, Eisenberg in 1961 for general homogeneous and concave utility function. So what they say is that if you write this convex optimization problem, so this is an optimization problem, right? This is called Eisenberg-Gale program. If you solve this optimization problem, you will get your price vector, and it may sound out of the blue and out of the air. It's not very natural program. It's like one single optimization problem I am giving you. If you solve this optimization problem, then whatever answer of prices you get, whatever answer of this optimization problem X you get, that X will indeed be the answer of these two problems actually. That's very surprising. It was like, I mean, it required thinking actually, how it can be. So what it does, this is called MI. M is the, so you sum it up over all the agents. What you are summing it up, you take the MI times log UI XI. So log UI XI is for each agent I multiply the money with the log of the utility for any consumption bundle. So here consumption bundles are unknown, right? So you can think of that this is kind of a modified utility. This is like I am summing it up over the whole agent population, and every agent's utility I am scaling it with the how much money they have actually, right? And then subject to the wealth constraint, if you solve this optimization problem, surprisingly you can show that this will give you the answer of Fisher market as well as exchange economy just by one optimization problem, and it's a convex optimization problem. Okay, so let's get into the computation of market equilibrium little bit. I'll just give you very glimpse of the ideas, not going to get into the detail. So before we get into solving this problem, see, we know that under certain condition equilibrium exists. Now when we come to sit down and solve it, actually find it computationally, then we have to keep in mind the two important differences, which is called gross substitutability property or gross complementarity property. So look at this. So this is the picture of the two products. One is Coke drink, another is Pepsi drink. If the price of one drink goes up, what do you think the price of the another drink will it go down or will it go up? Sorry, demand. If the price of the one goes up, let's say Coke become expensive, then what will be impact on the demand of Pepsi? Increase, right? On the other hand, look at these two products. One is gasoline, right, and petrol, and another is car. If the price of the petrol goes up, what do you think that demand of car will happen? Decrease, right? So can you see certain behavior here? Here are the two products where if I increase the price of one product, the demand of another product goes up. Here if I increase the price of one product, the demand of another product goes down. So these are just opposite behavior. These are called gross substitutable goods. These are called gross complement goods. Okay. Now what happens is, so far when we defined all this mathematical paraphernalia like this equilibrium, market equilibrium and those conditions, we never talked about whether given two goods in the economy they are substitutable or they are complement. They can be anything, right? But it so happens then when you sit down, so equilibrium will always exist, but when it comes to computing the equilibrium, it just so happen the problem with the gross complement goods, when there are goods which are gross complement goods, problems are generally hard. Whereas if the goods are gross substitute goods, the problems are relatively easier. This is the only hint I just wanted to give you, okay? They makes the problem harder, the presence of gross complement goods in the market actually, okay? Okay, so one more thing is, then we also talked about concave utility function, because the Arrow-Debreu theorem gives us the guarantee for concave utility function. So let's ask this question. So what decides the substitutability or the complementarity of the good? Suppose I am a consumer, I have two goods, right? So if I am consuming a bundle of two goods, the substitutable nature or the complementary nature, it will be dictated by what? It will be dictated by my utility function, am I right? For example, in the case of Pepsi and Coke, if I increase the price of, Coke, the demand for Pepsi is going up because of certain utility function, because even if at the same price I can get an alternative good, I'll still be happy. That's the nature of my utility function. On the case of petrol and the car, if the price of the petrol goes up, the nature would be that my utility function would be that by paying high price for the petrol, even paying the same price for the car, I may not be happy. So my utility goes down. And that is what is deciding the substitutable, two goods become substitutable or complement, that gets completely controlled by this utility function u. Okay? How you define the utility function u? That automatically will decide whether the two goods are complement or substitute. Number one. So then the question becomes is that are there some utility functions which are concave also and which also satisfy the gross substitutable property, because gross substitutable is easy to start with rather than gross complementer. So not all concave utility functions satisfy this property. For example, GS property holds in linear concave function, but GS property does not hold in piecewise linear concave. So this is an example of a piecewise linear concave function, and gross substitutability property need not hold in such kind of functions. Okay, and there is this another important function called Leontief utility. Okay, I'm not going to too many details for that also. Although it's a concave utility function, equilibrium will exist, but it's a much harder problem. Why? Because under this utility function, the goods becomes gross complement. So problem is much harder for computation. So in some sense, in summary, what I'm trying to say, even if you have a all concave utility function, equilibria will exist, but the computing that equilibria, that complexity depends on the nature of the utility, concave utility function. Because certain utility function, even though they are concave, they make the goods to be substitutable. Some utility function, they makes the goods to be complement. And if the goods are substitute, it is relatively simpler than complement scenario. Again, there is another interesting result which says that for any exchange economy which satisfies the gross substitutable property, if let's say all your utility functions of all the agents are such that the goods are only substitute, there is no complementarity nature, in that case Walrasian equilibrium is always unique. That's another interesting result. Okay, maybe then, okay, so this is like, you know, I'm just only flashing the vast literature on computing the market equilibrium problems. So there is a certain set of literature which works under linear utility function, which I told you that it satisfies the gross substitutable property. Then, so all of them are first of all work with the concave utility function, because that is where we know that equilibrium exists. But then there are some another set of literature which works with either piecewise linear and additively separable utility function, or piecewise linear additively non-separable function like Leontief function. All of these functions do not satisfy GS property. So broadly, the literature is divided into two categories, two verticals. One, those scenario where your utility function satisfy GS property, another where utility function do not satisfy GS property. And then again, depending on which equilibrium you are trying to compute, Walrasian, exchange or Fisher. Fisher is the simplest one to calculate, right? It's a very special case. So these are the literature. If people want, maybe you can look at the slides, and if you want to pursue your research in this direction, you can still look into it, right? Now, this is some more literature. Again, there is a much more literature even beyond what I had put in here and what I have managed to put in here. So these are some of the contemporary research direction. What if your goods are indivisible? See, so far in market equilibrium theory, what I talked about, whether it is tomato, potato, gold, petrol, they were of the nature where you can divide them, right? You can take half kg of something, 1 kg of something, 1.5 kg of something. They were divisible goods actually. But what if your goods are not divisible? Then problem become even much harder, right? For example, you take some objects like cell phones. Somebody is selling cell phones. You cannot divide half kg of cell phone or half of the cell phone, right? So their xij, they has to be integer variable, right? You cannot have them as a continuous variable. So all those previous optimization problems, the moment they are undivisible good, they take a completely different shape actually. Okay, number one. So there is this interesting thing called from Fisher market to Santa Claus problem, we call it actually. So there is a famous problem called Santa Claus problem. Of course, there are several variants of it. Okay, so this is where, I think it appeared in this stock in 2006. So what is Santa Claus problem in a very layman's language? So there is Santa who comes to give the gifts to the kids, and in Santa's bag, there are bunch of these kits, these gifts. I'm just picked up some gifts, and they are indivisible objects, right? Let's say 2 cell phones and 2 these watches and all that, right? And then Santa wants to give these gifts to the kids. Now there are kids actually, and these kids have certain utility over each of these good, right? For example, different kids wants different kind of goods, right? So if x11, x12, x1k, these are binary values. Binary value in the sense either it is 0 or 1, whether the kid is getting this particular item or not. So all the items in Santa's bag, they are put up as 1 unit item of each commodity. Think of that. Even if there are 2 cell phones, I will put them as 1 unit, let us say, just to make life simpler. Now, corresponding to each of these items, there is this variable called 0 or 1 variable. That's why this utility function is over this space 0, 1 power k, where k is the number of items here, right? So depending on which gift a kid is getting, this decides the kid's happiness. Different kids' happiness may be different way actually. Some kids may like cell phone more, some kids may like Apple Watch more, things like that. Now kids have no money, right? So in this setup, we don't assume that there is any money. Santa doesn't want money, right? But wants a fair division of item. Santa will be happy if kids are happy, right? So these kind of problems are little different from previous setup, where if you have to buy something, you should have money. But here we take money, throw away from the picture, right? And the person who is owning the gift or the item, he or she is not interested in earning money. What their interest is that whatever goods they have, that good should be allocated in a fair manner across all the consumers. So of course this does not work. This is not to do with competitive equilibrium, market equilibrium. The previous thing which I talked about, they are more to do with the free markets. But here this could be more to do with, let's say, government want to give the resources to different parties, let's say different states. There should be some fair division. Or a parents who wants to distribute the various items among their kids. All kids are equal, so everybody should be happy as much as possible. So these are very related problem, but not one and the same problem, right? But relatively harder problem, and maybe in the next week you will see, I think I saw the schedule there, people will be talking about fair division problems and fair allocation problem. So this is where, you know, this market equilibrium ends, and then we segue to different kind of journeys, right? Where money is not into the picture. So kids don't have money, Santa does not want money, but wants fair division of item. Santa's utility depends on the utility of the kids, right? And these are the criteria probably Santa can use. Maximize the minimum utility. So Santa may try to give the gift to the kids such that the most unhappy kid is as happy as possible. That could be the criteria. This is called egalitarian way of distributing the objects. Another criteria could be Santa may want to maximize the sum of the happiness of all the kids. This is called utilitarian way of, you know, allocating the goods. Another criteria could be maximize the geometric mean of the utility. If there are n number of kids, you take u1, u2, un, take its nth root. That is my criteria. It's after all Santa, right? It can fix whatever criteria it wants, but it should make meaningful sense, right? So these are few, you know, criteria which make sense. Another criteria, Santa sometimes may worry because kids comes and complain Santa that, oh, you gave better gift to him or her. So then Santa's problem could be, how can I allocate the gift so that no kids is envying from another kid actually, right? Whether a kid may be, sometimes, you know, kids may not be happy, but they'll be more unhappy if somebody else get the gift which they wanted, right? That could be their problem. So all of these things I assume and suppose that in the next week when some of this lecture you will see, right? And that's why I thought of, you know, giving you this primer on market equilibrium, that market equilibrium is another important aspect and this fair division is another important aspect, and how they are related but also unrelated at the same time. Okay? Alright, so maybe we will stop here. If you have any question then I can take, otherwise I guess this may be a good time to stop.